Okay guys, welcome to Chapter 2, Section 5, Equations of Lines and Linear Models. We're going to explore some of the other equations of a line. They all behave pretty similarly. As long as you understand the basic concepts of how a line works, you should have no troubles with this. Okay, so everything kind of begins with the slope formula. And in this first section, they're showing you how they derived the point slope equation from the slope formula. Basically by saying, hey, if you have one point y1, x1, and you use that in comparison to any other point on the line, which is referred to as xy, you can then create this equation where you have y minus y1 equals mx minus x1, where m is the slope. So basically, we're going to use that when we have a point and a slope. So in this first example, they said, hey, can you write the equation of a line given these points, or this point, -4, 1, and the slope, -3. So let's go ahead and fill in the equation. So we're going to have y minus 1 equals m, my slope, so -3, x minus -4. And just be careful about that sign. You know that that's going to end up flipping to be a positive. So y minus 1 equals -3, x plus 4. And now we can even turn this back into the standard or the mx plus b form that we're used to, slope-intercept. We can distribute this -3 in, y minus 1 equals -3x minus 12, and then we can add our 1 to the other side and get y equals -3x minus 11. And now this, of course, is in slope-intercept form, that y equals mx plus b that we're very commonly familiar with. Okay, now we can also use that same point slope formula if we are given 2 points, because if you have 2 points, we can actually calculate the slope. So let's go ahead and lead by calculating the slope. Let's do -4 minus 2 over 2 minus -3. And no matter what order you put it in, you should get -6 over 5 as the slope. Okay, and now once we've got that, we can use either point and you would get the same result. So I'm just going to use the first one that they've given us, and we would set up the formula and get something like this. Y minus 2 equals -6 over 5 x minus -3. Okay, and once again, just be careful about that sign because it's minus negative. We have this happen. Now, they asked us to put the result in standard form, which is ax plus by equals c. So what I'm going to do is I'm going to multiply the 5 to both sides. Okay, and we get something like this. 5y minus 10 equals -6 x plus 3 in parentheses still. Now, we can simplify this further. Let's distribute 5y minus 10 equals -6x minus 18, and we'll rearrange a little bit to get it back into the correct form. So we've got 6x plus 5y equals -8. And so that is in standard form. So all I did was rearrange the pieces after I distributed. Okay. Now, point slope form is actually where we end up building the slope intercept form from. And that basically comes from setting one point to be the y-intercept by basically putting x1 to be 0, and then the number that ends up on the other side, that mx plus b, that b section, works out to be the y-intercept of the line. Let's apply our slope-intercept form rules here. So what we're going to do is we're going to go ahead and convert this equation into slope-intercept form. So 4x plus 5y equals -10. Now we'll subtract the 4x to the other side. So here we go, -4x minus 4x. And I've got this 5y equals -4x minus 10. Let's divide by that 5, and we get this. So now we have y equals -4 over 5x minus 2. And we've kind of found all the key information here. So this is my slope, m equals -4 over 5. And this is going to be my b value, So if b equals -2, my y-intercept is going to be 0, -2. Okay, and so quickly from this equation, we're very easily able to find the slope and the intercept because it is, of course, slope-intercept form. And so once again, basically, we solve for y, get y by itself, you're in slope-intercept form, and then we just pull the numbers. Okay, so from example 3, we can see that we can kind of generalize this. This is kind of a shortcut on how you can find the slope from standard form, -a/b. You can always just convert it into slope-intercept form, so it's not really super duper important, but it is something you can use to help you shortcut this process. Okay, all right, so now they're asking us, can we write a line through the points 1, 1, and 2, 4? And then can we go ahead and express that in slope-intercept form? So the easiest thing to start with is, of course, let's find our slope. Okay, so here we go. We've got 4 minus 1 over 2 minus 1, and I get 3 over 1, which gives me a slope of 3, right? And so with this slope, we're now going to be able to set up our basic equation. Let's use point slope form, and we'll just let it convert into our mx plus b form, right? So using point slope form, we've got this y minus 1 equals 3x minus 1, using, of course, the very first point. Let's go ahead and distribute this 3 in. Y minus 1 equals 3x minus 3. Add our 1 back to the other side, and we've got in our mx plus b form, 3x minus 2. And so, of course, we've now got our slope and our intercept, right? So m equals 3, b equals -2. So if I were to draw this graph, essentially what I would do is I would put my first dot at 0, -2, and I would climb up 3 spaces and go over 1 space because my slope is 3 over 1. So I treat this as my rise over run. Okay, and so basically we'll just go 3 spaces up to 1 and then go 1 space over. And we can repeat this process to make as many points as we want. Okay, and I think that's enough for me. Let's go ahead and draw that line in. So essentially this is what the line looks like. And you could continue it backwards as well, going down 3 and back 1 space. Okay, so find the slope. That's kind of the key thing to start all of these. Okay, let's use this graph, and they want us to first find the slope and both intercepts, and then write out an equation that defines this line. So this one's actually pretty simple. If you look closely at the graph, you can see there are 2 points where we cross the axes, and we find some easy intercepts there. So my x-intercept is, of course, -3, 0. My y-intercept is going to be 0, -1. Now notice, when you do the y-intercept, the x is 0, and when you do an x-intercept, the y is 0. So you should only have a value for the intercept that you care about. So a y-intercept, you should only have a y value. X-intercept, you only have an x value. And then my slope, right? So it's pretty easy if we just think of our slope as rise over run. So when I go up 1 space, I went 1, 2, 3 spaces backwards. So my slope is going to be rise 1 space up over 3 spaces backwards. So I count that as a -3. And basically that is just a -1/3. You can put the negative in either spot, really. And so now we can write the equation of our line using this. Of course, y-intercept and slope makes it very easy for us. Y equals -1/3 x minus 1. And there's my equation of the line as well. Okay, a few things about these lines. So the equation of a vertical line is always x equals, and the equation of a horizontal line is y equals. You can see that they would be equal to the respective x or y value from any point on the line. Okay, so basically they are opposites of each other. If you have x equals a number, that line is a vertical line. The x is never shifting. Okay, that is known to have a slope that is undefined. And then a horizontal line, a flat line going through a number, is a slope of 0. Okay, parallel lines are considered to be lines that have the same slope. Basically, those would be lines that go in the same direction and essentially could never cross each other. Okay, and then perpendicular lines. So two lines basically that make a 90-degree angle when they cross. Their slopes are known for being negative reciprocals of one another. Essentially, they are reciprocals, flipped fractions, which have opposite signs. So I'll give you a quick example of this. Maybe something like 1/2 and -2/1 would make perpendicular lines as slopes. Okay, so let's write some line equations that are parallel and perpendicular to these lines, and they are based off of this point 3, 5. So they have to pass through this point, and they should be in that correct slope. Okay, so the first thing to figure out is, of course, what is the original slope? And so we can solve this using either the shortcut -a/b, or we could use solving this into slope-intercept form. Okay, so we'll go ahead and solve this into slope-intercept form. So 2x plus 5y equals 4. Bring our 2x over, 5y equals -2x plus 4. And then y equals -2 over 5x plus 4 over 5. Okay, so the parallel line is going to have a slope that is equal to this number, -2 over 5, and the perpendicular line is going to have the opposite reciprocal slope, which is 5 over 2. Okay, and now we basically just need to draw a line that passes through the correct point, which is 3, 5. So let's again, since we have a point and the slope, we'll use point slope form. Y minus 5 equals -2 over 5 x minus 3. Okay, and we can of course distribute this and simplify a little bit if we want to get it back into mx plus b. We can also work it back to standard form, okay, and by doing some multiplication here. So two things we can end up with. First, if we distribute this, we can have y minus 5 equals -2 over 5x minus 6 over 5, sorry, plus 6 over 5. The two negatives cancel each other out. And then, of course, subtract or add our 5 back to the other side. Y equals -2 over 5x plus 31 over 5. So that is after you add this 5 to both sides. Okay, so this is one version. This is the slope-intercept form. Okay, and then we'll also convert into standard form. So standard form, of course, would be if we multiplied by 5 to both sides. So we get 5y minus 25 equals -2x minus 3. We'll distribute. 5y minus 25 equals -2x plus 6. Let's rearrange, and then we'll be in the right place. So 2x plus 5y equals 31. Okay, and that's the standard form. Okay, so again, these forms just come from rearranging and getting the pieces in the right way. So standard form has both x and y on the same side, and intercept form has the y by itself on the right-hand side. Okay, so let's go ahead and do the other version of this, which is with the perpendicular line. So same idea. Let's go ahead and start with our point slope formula. So we've got y minus 5 equals 5 over 2 x minus 3. And again, from this point, we can convert to both forms. So let's start with the intercept form. So we distribute y minus 5 equals 5 over 2x minus 15 over 2. And we can subtract or add our 5 back to the other side. Let's add this 5. Okay, and we get this, y equals 5 over 2x minus 5 over 2, and that is going to be our slope-intercept form. Okay, and we can also take our equation the other way into standard form. So this is slope-intercept form. And let's go for standard form now. So we'll multiply this 2 back to this side. So 2y minus 10 equals 5x minus 3. Let's distribute this 5. 2y minus 10 equals 5x minus 15. And let's rearrange so everything is on the correct side. Okay, so let's go ahead and move this back around. So negative 5x plus 2y equals negative 5. Now, warning, this is not allowed right now. You cannot have this negative here. And so what we do is essentially we can divide by negative 1 and flip all the signs back to being the correct way. 5x minus 2y equals positive 5. Okay, basically the x term is never negative here. So x term must be positive. Okay, and that is in standard form. Okay, so because everything starts from x as our independent variable, we never leave that with the negative coefficient. We always want that to be our positive coefficient. Okay, and so once again, once you have the initial line equation written out using this point slope form, it's very easy to go to either of these. Basically, you can distribute and then you can work your way to getting y by itself. You can even do the same thing to get to the standard form. You can even distribute first and then finally at the end fix the fractions, and it would still come out the same way. There's a lot of things you can do as long as you're careful with your algebra. Okay. Okay, and then on this last page, we've got this table, which is a great summary of all the different forms of a linear equation that we've seen. So it's got slope intercept, point slope, standard form, and then it's got a nice little reference for how horizontal and vertical lines work. So this is a good reference in case you ever need to look back at it. Okay, good luck and happy studying, guys.